So now that we have managed to clean the BEA data to become just our EITC observations, and we've also cleaned the Walmart openings data, we may actually want to merge these data. Say we've been cleaning the EITC data so that we can use them in an analysis of the impact of Walmart. We may want to merge those data. And so the first thing that you need to ensure you have is a common identifier in all data files. Now, I already knew this, so I made sure that we called that common identifier county FIPS. Obviously, the Walmart data are not going to observe every county. It's only counties that got a Walmart. So the BEA or the EITC data are going to include more counties than the Walmart data. It is also the case that, and I'll just remind you now, it is the case that in reality these counties have changed over time, and there are a number of, for example, these cities in Virginia that are contained or surrounded by a county but are not part of the counties, but in some data sets they are included as part of that counties, and others they aren't. So you want to make sure that you have applied all those fixes. We have not done that in these data. If we were actually doing this analysis, we would want to apply those fixes, but we are not going to do it. But to the extent that we are going to merge these data, we have these common identifiers. I've told you how counties might change, or units might change, for example. Boundaries or codes might change over time. So let's create a new do file to merge stuff. So you can do it entirely from scratch, or you can do something like this. I'm going to call this Walmart EITC merge. Merges the Walmart openings and EITC data. Now, something I haven't done with these data, with these do files, but which you may want to consider doing, is actually changing the date to reflect the date that they were last modified. So here it's actually the 27th. And you want to make sure, since you open this log, that you have down at the bottom something which closes the log. And let's save that. And we have this merge folder here, so let's just save it as the exact same thing that we are calling the log file, Walmart EITC merge. In fact, rather than saving in the clean folder in build in log, let's change that to merge as well. So those are the sorts of little things that you need to make sure that you do if you copy and paste rather than creating a new banner, an absolutely new do file every time you want to create a new do file. Once you know that you've done that, you can start doing what you actually want to do. So first thing we're going to want to do is load the cleaned Walmart data. Bless you. So if you're not sure of the file path of that Walmart data, you can just go to the bottom of your store openings data. It could be store openings or store openings _ clean, I think I said before, so I could save that and just run it again. Oops. And if you do that, you may want to actually then erase the other one that was there if you had just store openings. But if this is what we're working with now, then let's go here and let's say use this clear. And that loads those Walmart data that we had cleaned and saved yesterday. Remember, we also included all those extra variables that maybe were not actually of interest for our analysis, but we were practicing certain commands on. We included the variable labels, the value labels. Now maybe we want to restrict the Walmart data. You can restrict it further. Maybe it's not cleaned as you'd actually want it. If it is cleaned as you'd actually want it for other purposes, then you can, in this case, just restrict it and merge it with your EITC data. I am actually going to say, now that we've done this, we're going to further restrict our Walmart data in the clean file because we don't want a lot of these variables in reality. So let's say that we only want to keep the county FIPS code and the year the first store opened in each county. Now, as I said, again, you may actually want to have more variables in your Walmart clean data. Let's assume that we do not for this project, in which case we'll put it in the store openings clean do file. So now restrict the data, bless you, to include only county FIPS codes and observations of the year the first store entered a county. How do you think that we would want to do that? If you think back to how we created these data yesterday, given the variables that we have, what might be a nice, simple way to do what we want to do? We actually did it yesterday.
Okay. Wait, was that the question you were asking?
So we want to restrict these data. We only want to have county FIPS codes and the year that the first store entered. So really we only want one observation for every county that is included. And obviously not every county is going to be included. So what might be a good way to do this? Well, I would say you could just collapse min open year by county FIPS. You do that, you're left with 1,795 observations. And if you remembered yesterday, we had 1,795 counties, unique counties in the data. We now have one observation for each county, and we have the year that the earliest store was built. So we may have had multiple stores built in a county in the first year it saw a store. The open year command did not distinguish between those, but it doesn't really matter because we're interested in year rather than date. If we had wanted to get the date of the first store and actually have that store observed, we could have said min open date and done a few other things. So now that we've got this, let's assume that that is actually what we want. Okay? So you can either just run and save this, or you can save the do file and run it all again. It should run quite quickly, so you might as well do that.
How do you open multiple do files in that same window?
Just open. And in fact, you should always be doing that, right? Because you've got to run your settings file before you run everything else. So other than your settings file, you should pretty much always be doing that. So now if we load this, it's the exact same file that we just created through our store openings clean do file. What do we want to do now? Well, maybe we only want to keep counties whose store first opened after 1989. So let's say we did want in our store openings data to do this, but for whatever reason we wanted to have all our years of observation included there. But now here we want to, and we should call this load the Walmart data. Now we should say we want to restrict to counties which saw first store after 1989. So if you list, you can see, well, we've got a bunch of counties that saw their first store in like 82 or 86 or 80. We don't want to include those. So we only want to include counties. We only want to keep if open year is greater than 1989, or you could say greater than or equal to 1990. You may also note that you don't like this this label. I think this is fine enough, but it's not fantastic. You could change it if you want in the store clean data or store clean do file or this. I'm just going to leave it as is because I think min open year is clear enough. It's up to you. But if we do this, then we are left with 798 counties. So we've just lost nearly 1,000 counties. Let's preserve this for now. And now let's merge the data. So this is going to be the first time that you have merged data, at least in this course. We want to merge it with the BEA data. In particular, the EITC clean data that we just created. So I'm actually not going to keep this preserve in the future, so I'll keep it outside of my label and I'll delete it later. But now I'm going to say merge with the EITC data. Now there are a couple of different ways that you could do this. First, you could say merge one to many, and there are a few different types of merges you could do. You could do merge one to one, merge one to many, M for many, merge many to one, or merge many to many. That last one you should be very careful about. But let's merge this and then let's consider what we're doing here. So merge one to many, and then you want to tell Stata the variables that you are going to be matching on. So if you are going to merge these data, you've got to match them somehow, right? Otherwise, one variable in your EITC data could be applied to absolutely any other observation in your Walmart data. But in fact, you want to match them on county. If rather than keeping only the year that a store was first observed, you actually had all of your Walmart data here, you may actually want to have some common variable called year in both data sets and then match on both county FIPS and on year. We're not doing that. We're only keeping the year that the first store was observed. But you can merge on more than just one variable. In fact, if you try to merge on just one variable and you try to do like a one-to-many or a one-to-one or a many-to-one, and that variable does not uniquely identify the data in the data set that you said would have one of these variables, then the data will not merge. So you do need to be careful about this. So it needs to uniquely identify the data in this data set is going to be the master data set. So on the left-hand side of the colon is going to be the master data set. The master data set is just going to be the data set that is currently loaded. The using data set is going to be the data that you are going to now say using, and then you're going to define it. And that can have, in this case, because we said M for many, that can have many instances of county FIPS. And in fact, we know that each county FIPS code is observed 17 times in the EITC data because we have 17 years of observations for each county FIPS. So now let's say, okay, proj dir slash dta slash clean slash bea slash EITC, what we called it, 9006 underscore cln.dta. And let's see what this does. So remember, we have right now 798 observations, 798 distinct counties. We only have 17 unique open years, but that's okay. So let's apply this. Run. And because we did not include any options in the merge, in particular, we did not include any options saying to suppress this from popping up or from creating this new merge variable. What's going to happen is this is going to pop up and tell you what has been matched and what hasn't been matched, and in which data set the non-matched data exist. So we have here 39,112 observations that were not matched. We have, out of those, 29 observations in our master file, which is our Walmart file, and 39,083 in our using file. And then we have 13,073 that were matched. Now it says here merge equals to 1, merge equals to 2, merge equals to 3. Beside that, you can even say tab underscore m or tab underscore merge, which is this variable right here. And you can see that's exactly what we got from this. Now, it makes perfect sense that given we have observed most counties, not all, but most in the US in our EITC data, but we have only observed counties that Walmart entered in our Walmart data. It makes sense that we would have more counties defined in the EITC data, or more counties observed in the EITC data than in the Walmart data. So it makes sense that we have a bunch of non-matched observations from our using data, our EITC data. But it may not make sense to you why we would have any unmatched observations from our Walmart data. It's possible the Walmart data include Alaska, Hawaii, because we dropped those. But that's not it. What's actually going on here is that we did not make those changes that we said we do have to actually consider making. Some of the counties that are observed in the Walmart data are simply not observed in the EITC data because we have not ensured that those changes to counties were taken care of. We're not going to, like I said, we're not going to go fix that, but you do need to keep that in mind. In fact, there are probably, beyond these 29 observations, there are probably a number of counties that may have changed over the years that now have FIPS codes that do match, but are in fact not the same counties over the years. So just things to keep in mind. So anything that we would get from this would be problematic because we haven't made those changes. We're just not going to worry about it. Let's, now that we've done that, we could just say keep if merge equals to 3. We're not going to do that. We're going to actually include that in our merge command. So you can say help merge, and you can see the options that are available to you. Keep using is one. Maybe you only want to keep certain variables from the using data. You don't want to have all of them. If you've got 2,000 variables in your using data, and you've got, you know, I don't know, 100 in your master data, maybe just combining them is going to be problematic if you don't have the right version of Stata, or maybe you just don't want them. You can also generate a different name for this merge variable. I just keep as that. You can no generate, so it doesn't create that merge variable. You can also do things like all of these that are included here. So I think we can say here, no generate, and keep. I think that should work. There we go. So now we have not generated the merge variable through this no generate option, and we only want to actually keep. If merge was equal to 3, that's the matched ones. Again, that would not be accurate if we were actually running this analysis. Just need to emphasize that. But now that we've done that, what we have is a series of county FIPS codes, observations of county FIPS for each year, and we have an open year associated with it and earned income tax credit totals.
What was the code you just did for the merge?
Yeah, just keep 3. So why do we use a one-to-many merge? Well, for each observation of county FIPS in our master data, the Walmart data, we only have, or for each county, we only have one observation, but we have many observations in our using data, so that's why we use one-to-many. If we had actually been using the EITC data as the master data and the Walmart data as the using, then we would want to use a many-to-one. So let's restore this right now. So now that we've done this, before we've done the merge, we could also try using join by. Join by would keep the same variables of interest given what we're trying to accomplish. You do need to be careful not to use join by in place of merge if it's not going to do the right thing. But join by with the EITC data. So join by, you don't have to specify like the one-to-many, but you need to make sure that you're using it in the right situation. Join by county FIPS using. This is essentially going to do a pairwise matching across those two data sets. Now, because we only have one observation of county FIPS for each county in the Walmart data, it's going to be appropriate. And because we have many observations in the other. So now we can just do the exact same thing. And you see that you're again left with 13,073 observations. So you can use either of these, but again, be careful that you're using both merge and join by appropriately. And join by, we didn't have to specify any options, but we're still not getting anything like that merge variable. So we don't know by using join by that we actually had that set of observations in the 29 observations in our Walmart data that we did not match on. Join by is not going to tell us that. So maybe now you list these data and you say like, okay, this looks actually like it's kind of been sorted nicely. But if we had done the merge command, in fact, if you go back and do the merge rather than the join by, and let's do that just for our purposes. We can get rid of the preserve now. You go back and do this and you list, you see that county FIPS seems to be ordered, but we may not have, maybe we want year first and not open year. Or maybe things are not sorted right. Like, sure, there's this ordering of county FIPS, but it seems to first be matched on year, or sorted on year, and then on county FIPS. And maybe that's not what we want. Maybe we actually want to observe every year for each county before moving on to the next county. So let's sort now, and you can see down here it doesn't tell you what it's sorted by, but we can puzzle out that it is sorted on year. Now let's sort by county FIPS and then on year. And now if you hit list, you see, oh, great, now we've actually got county FIPS 1005, that's the first one that we observe, and we have it for every year through to 2006 before we go on to the next county. But maybe we try to figure that out, but it's like we're getting a little confused because open year is here and it seems to be 1990ing a lot. And then we're like, wait, what? Is that right? Oh no, year is over here. Well, that's a little confusing. So maybe we actually want to order our variables differently. So right now they're ordered as county FIPS, open year, year, EITC, tote. Maybe we actually want to order them as county FIPS, year, and then let the remaining ordering in this current data set continue to exist. So if we do that, now that we list them, oh great, now we've got county FIPS and then year, and we can see exactly what we want is happening right off the bat. It's very clear. And then we can see we've got open year here. And it looks like open year is 1990 for a lot of these. But in fact, if you think about it, open year, remember, maybe you want to rename open year. Open year is the year of the first store opening in each county. So obviously that has to remain the same for every county over time. The year that something happened in that county is the same regardless of what year you're observing after the fact. So it first opened in 1990 in 1005, so for every year of observation it was the year the first store opened was 1990. That's also true for 1013, but then we get to 1019, the year that the first store opened was 2003, and so that's going to be consistent throughout all of them. Now that you've done this, you can just actually star out the join by. Maybe you want to keep it in there, but you star it out so that it doesn't try to run that when you run your do code, but the code is there if you want to do that instead. And then you can save your data.
Does it matter which one we start out, the join by or the merge here?
No, not really. I just wanted to show you like a different sorting that existed from the merge rather than the join by. Actually, let's see. Sorry. What is our directory structure? Now we have to look at the directory structure for our data files. So, data, we have only clean and source. Clean, we have all these. Maybe we now want to create a new folder in our clean data called merge or merged. Once we've done that, we can call this Walmart EITC merge.dta and replace. And we see that it'll do that. And now let's run the whole do file after we save it, and it'll create a log file for us as well. Any questions about that? All right, this is going to be your homework for tonight. I want you to create a new do file, which, and in fact, you may want to create a number of new do files. Ones which clean the EITC and Walmart data with state by year rather than county by year units. For the Walmart data, it would just be state in general. And then I want you to merge them. I also want you to make sure that your Walmart data are observing only the first store by state, like the year that a state got its first store rather than just a county. And so essentially do everything that we just did, but do it by state. And the reason I want you to do that is to make sure that you understand what's going on. You can write your own code and figure out those subtle differences. And I showed you one of the way you can identify states using the floor function with CityFips divide by 1,000. That's going to be a useful thing for you. Just summing up what we did go over yesterday and today, we went over what was data cleaning, basic data manipulations, then intermediate data manipulations, and I include reshaping and merging and appending the data as intermediate data manipulations. They obviously can be quite complex at times. So make sure you send me your exercise 7 do file, the one for the state data.